Okay, folks, welcome back. This page of notes is going to talk about force versus displacement graphs, which is just another way for us of getting the work done. So here we go. We're told we have a horizontal net force acting on an object as it moves 30 meters horizontally. A graph of this force acting on the object is shown below. So here's our object right here. We're net force pushing to the right, so that's all we need to worry about. Displacement to the right, and then we're looking at the angle between us moving to the right with a force and displacing ourselves to the right because of that force. Those two are in the same direction. If you laid this arrow and this arrow, those two vectors on top of each other, there would be no angle to measure. So we're talking the cosine of 0 in this example. So our work done by the force equation, FD cosine, we're using cosine 0, which is just positive. Anyway, so we have a force versus horizontal position, right? So as we change our position, we're talking about our horizontal displacement graph here. So this is the force, and then here's our x-axis where we have a force of 0. Okay, so we can see that we have a period where we're above the x-axis and a period where we're below the x-axis. That's going to be significant. Let's see exactly how and why. So the work done by a force equation is the force times the displacement. And again, we're saying the cosine of theta is just giving us +1. So, our displacement, if we go from 0 meters to 5 meters, we've displaced ourselves 5 meters. If I go from 10 meters to 20 meters, I've displaced myself 10 meters. If I go from 10 meters to 30 meters, I've displaced myself 30 meters. So in terms of breaking this graph up into shapes that we can use and look for, right now we're looking for how we can multiply a force into displacement. So we've got displacement basically represented on adjacent points for our horizontal position axis, our x-axis. And then we have force on the y-axis. So doing any sort of a force height calculation multiplied by a displacement's value calculation is going to give you the area of this shape right here. So the area of our force versus displacement or horizontal position graph is going to equal for us the work done by an individual or net force. So if we have a force versus position graph, we can get the work done just by calculating some areas. So we see again periods where we're above versus below the x-axis. So these would all be areas where positive work was done, and then this would be where negative work was done. And to get the total work, we would just get the total area and break it up into shapes so we can easily calculate the area for. So again, we have a big triangle here where displacement is 0 to 10, and the force goes from 0 to 10. So it's constant force for that section. So 10 times 10 is going to be 100. Here we have another 100, right? 10 and 10, and then we have another half of that, 1/2 base times height. So the base is still 10. The height from here to here is still 10, but it's a triangle, so it's half that. So 150 plus 100 is 250. And then we have this area here. So that's 10 meters on the x-axis, and then 15 on the y, so 150. So 250 minus 150 is 100 again. Did I do that math right? I did. The net total work. All right, so calculated all these individual areas. There you go. I lucked out this time, didn't I? Okay, so there you go. If you have any questions, please, as always, find me, flag me down, and ask away.